Welcome to our deep dive on clean code principles.
Clean code principles.
You gave us quite a stack of readings from Clean Code by Robert C. Martin.
Yeah.
So looks like someone is really trying to make their code not just functional, but a joy to work with.
Yeah, absolutely.
All that good stuff. Readability, changeability. So we'll be your guides to extracting the golden nuggets of wisdom today
Sounds good.
from this pretty dense material.
Yeah, it's a classic for a reason, right?
Yeah.
It gets into the nitty-gritty details that can really make or break a code base over time. We're talking like seemingly small choices that have a huge impact, like
Yeah.
how you name your variables or how long your functions are.
Let's start with names then.
Okay.
It seems basic, but the book really hammers home how important it is to choose names that reveal what your code is actually doing.
Right.
It's almost like labeling ingredients clearly in a recipe.
Exactly. Imagine trying to follow a recipe where everything's just labeled ingredient A, B, C.
Right.
It'd be total chaos. Good names, they act like signposts in your code, making it instantly more understandable.
And the book even compares choosing a variable name to naming your firstborn.
Right.
Maybe a slight exaggeration, but makes you realize how much thought should go into it.
I mean, there's an example in the book that really drives this point home.
Okay.
It starts with this function called getFlaggedCells,
Okay.
but the original code is just really hard to follow because of these generic variable names and these data structures.
Right.
But simply by renaming these variables to things like game board and flagged cells
Okay.
and introducing a cell class, the code just becomes so much clearer.
Wow.
And the best part is the core logic doesn't even change.
Yeah.
It's just about clarity.
So the takeaway here is that choosing these really descriptive names makes a world of difference in terms of readability.
Yeah.
I know I've personally wasted countless hours trying to decipher poorly named variables, and I'm sure I'm not the only one.
I've been there.
So this is something I'm definitely going to be more mindful of moving forward.
So speaking of making code easier to understand, let's move on to functions.
Okay.
Clean code is very adamant that functions should be short, focused, and have a single, well-defined purpose.
I've heard that before, the idea that a long function is like a sentence that never ends.
Yeah.
But why is that so important?
Well, for starters, short, focused functions are much easier to test.
Okay.
You can isolate specific pieces of functionality and just verify that they're working correctly. Plus, they're just easier to understand and reuse in different parts of your code base.
Right.
A long, rambling function, on the other hand, can just be a nightmare to debug and maintain.
The book uses a great metaphor for this.
Oh, yeah.
It says your code should read like a well-written newspaper article with increasing levels of detail as you go deeper.
Right.
Each function's like a paragraph.
Yes.
Focusing on one specific aspect of the story.
And if we take that metaphor a step further, each function should really be like a mini essay. You know, a clear topic, which is the name, a concise body, which is the code itself, and a single conclusion, which is the return value.
I like that.
It just makes the whole code base much easier to digest.
Now, this next section on comments was a bit of a surprise to me
Okay.
because it basically argues that comments, while sometimes helpful, can often be a sign that your code isn't as clear as it could be.
Yeah, ideally your code should be so self-explanatory
Right.
that it doesn't really need a lot of comments.
Right.
Of course, there are times when comments are necessary,
Of course.
like explaining a complex algorithm or a really tricky business rule. But if you find yourself writing comments just to explain what your code is doing, it might be a sign that you need to refactor and make that code itself more expressive.
Yeah.
So it's not about just adding comments, it's about thinking about, is there a way I can make this code speak for itself?
The author actually calls out several types of bad comments, too,
Yeah.
like redundant explanations, misleading information, and even those mandated by overly strict coding standards.
Like just pointless comments that are just there because someone told you you had to write them.
Yeah, exactly. It's a good reminder to really be thoughtful about when and why we're using comments.
Absolutely.
So we've talked about meaningful names and well-structured functions,
Hmm.
but the book also dives into the visual aspects of code.
Yes.
Things like spacing, indentation, and even file length.
It matters.
I have to admit,
Yeah.
I sometimes overlook these things, but the book makes a pretty compelling case for why they actually matter.
Yeah, it's all about making your code easier to read and understand.
Okay.
Think about it this way. When you pick up a newspaper, you don't want to be confronted with a wall of text, right?
Right.
You want clear headings,
Yeah.
paragraphs,
Right.
visual cues that help you navigate the content.
The newspaper analogy works really well here.
I think so too.
Because just like in a well-designed article, good formatting in code helps guide the reader's eye and make it easier to grasp the overall structure and flow of information.
Absolutely. Good formatting isn't about being pedantic. It's about recognizing that the human brain processes visual information rapidly.
Yeah.
So by structuring your code in a clear and consistent way, you're essentially taking advantage of that innate ability and making it easier for others and your future self to understand your code.
All right, so we've covered the basics, making sure our code is well-named, well-structured, and easy on the eyes.
Hmm.
But now things get a little bit more conceptual as we move into objects and data structures.
Right. This is where we start thinking about how we organize our code at a higher level.
Okay.
And the book draws this important distinction between objects, which encapsulate both data and behavior,
Okay.
and data structures, which primarily just expose data.
I'm with you so far.
Yeah.
But why is this distinction so important?
It comes down to good object-oriented design.
Right.
Mixing objects and data structures can lead to code that is confusing and difficult to maintain.
So are you saying that objects are, the recipes and data structures are like the raw ingredients?
That's a good way to think about it. Objects provide a structured way to organize and interact with data,
Mhm.
while data structures are kind of the building blocks of that data.
Okay.
And understanding the difference between the two really helps us make better design decisions and write more maintainable code.
And the book actually contrasts procedural code, which often relies heavily on data structures,
Yeah.
with object-oriented code.
Yes.
So what are the key takeaways from that comparison?
So what's fascinating is that each approach has its strengths and weaknesses.
Okay.
Procedural code tends to be easier to understand when you're adding new functions.
Mm-hmm.
But it can be more difficult to add new data structures because all the existing functions might need to be modified.
Oh, I see.
With object-oriented code, it's the opposite.
Okay.
It's easier to add new classes, but it can be harder to add new functions because of those potential ripple effects across the code base.
Yeah, that makes sense.
So it really highlights the fact that there is no one-size-fits-all solution in software design.
Mhm.
It's about choosing the right tool for the job
Right.
and understanding the trade-offs involved in each approach.
So as you're working on your own projects, ask yourself, am I using objects and data structures in a way that makes my code clear, maintainable, and adaptable to change?
Mm,
Now, no matter how well structured our code is, things can still go wrong.
of course.
So let's talk about error handling, an area that the book stresses should be clean, concise, and not overshadow the core logic of our code.
It's all about being prepared for the unexpected, right?
Yeah.
Error handling is kind of like a fire alarm.
Yep.
It's essential to have in place, but you don't want it constantly blaring when there's no fire.
Right.
The goal is to handle errors gracefully without disrupting the main flow of the code.
I've definitely seen code bases where the error handling logic is so intertwined with the core functionality
Yeah.
that it becomes nearly impossible to understand what the code is actually supposed to be doing.
Yeah, you want to avoid that.
Yeah.
Clean code offers several techniques for handling errors effectively,
Oh.
using exceptions appropriately,
Hmm.
and clearly defining the normal flow of your code.
Right.
It's about anticipating potential issues and having a plan for dealing with them without cluttering up that main logic.
There's a really good example in the book about a device controller where using exceptions leads to a much cleaner separation of concerns.
Yeah, instead of having error handling logic scattered throughout the code, it's centralized and handled in a way that doesn't obscure the main functionality.
I like that. So it's like having a designated fire escape route.
Exactly.
It's there if you need it,
right.
but it doesn't interfere with the normal flow of traffic.
Precisely.
So the key takeaway here is to think about error handling proactively
Yes.
and design our code to gracefully handle those inevitable bumps in the road.
Bumps in the road. I like that.
Speaking of bumps in the road, let's talk about another potential source of headaches:
Okay.
third-party code,
Right.
whether it's libraries, frameworks, or APIs.
Yep.
We often rely on code written by others,
We do.
and that can introduce its own set of challenges.
Absolutely. Relying on external code can be a double-edged sword. It can save us time and effort,
Of course.
but it also means we're giving up some control.
Right.
And the book has some really insightful advice on how to manage those dependencies effectively
Okay.
and protect our code from the inevitable changes that come with using those external libraries.
The author actually shares a personal story about this,
He does.
working on a radio communication system and having to interface with a transmitter subsystem that wasn't fully defined yet.
Yeah, and it really highlights the challenges of working with those external dependencies that you just don't have full control over.
Right, because you might be relying on something that's still in development.
Yeah,
or the API might change unexpectedly. So
exactly.
how do we protect ourselves from those changes?
Well, one technique is to create these clear boundaries between our code and the external code.
Okay.
And this can be done by wrapping those external APIs or using adapter patterns. So by introducing this layer of abstraction, we can kind of insulate our code from the specifics of the external library
Right.
and minimize the impact of any changes.
That makes a lot of sense. It's like having a buffer zone
Yeah.
between your code and the potentially volatile world of external dependencies.
A buffer zone, yeah, that's a great way to put it.
So think about the libraries and frameworks you use in your own projects.
Yeah.
Are you managing those dependencies effectively?
Right. Are you creating those clear boundaries
Yeah.
to protect your code from those unexpected changes?
These are crucial questions to consider if you want to build a code base that's truly maintainable in the long run.
Absolutely.
All right, we've talked about writing clean code,
Yes.
but what about testing that code?
Right.
The book is pretty adamant that clean code and clean tests go hand in hand.
They absolutely do. Tests are not an afterthought. They are an integral part of the development process.
And it criticizes that seems like enough mentality
Oh, yeah.
when it comes to the number of tests.
Yeah. I mean, the book advocates for a much more rigorous approach.
Yeah.
Your test suite should really test everything that could possibly break,
Okay.
leaving no room for ambiguity or assumptions.
Right.
It's about achieving a level of confidence in your code that goes beyond just hoping for the best.
So it's not just about having some tests, it's about having comprehensive and thorough tests
Absolutely.
that truly give us confidence in the code's correctness.
Precisely. And one of the key principles the book highlights is that tests should be clean,
Okay.
just like production code.
Right. It's easy to fall into that trap of treating test code as like second-class citizen.
Oh, yeah.
But that can lead to a real tangled mess
It can.
that's difficult to maintain
Mm.
and ultimately hinders our ability to test effectively.
It really does. The book shares an anecdote about a team that wrote dirty tests.
Okay.
They had tests, but they were so convoluted and complex that they actually became a liability rather than an asset.
Interesting.
They ended up slowing down the development process rather than speeding it up.
So it's a good reminder that if we don't care about the quality of our tests, they won't be able to effectively serve their purpose.
Exactly.
So how do we write clean tests? What are the key principles?
It really boils down to three things: readability, readability, readability.
Readability, just like with production code.
Exactly.
But what makes tests readable?
The same principles that make all code readable:
Okay.
clarity, simplicity, and density of expression.
Yeah.
Saying a lot with as few expressions as possible, making the test's intent crystal clear.
The book provides a good example of this from fitness,
Yes.
where the initial tests are really cluttered with details and repetition.
It's hard to see what's going on.
Yeah, exactly, making them difficult to understand.
Mhm.
So how do they go about cleaning those tests up?
By applying the principles of clean code.
Okay.
Things like extracting common logic into helper functions,
Right.
creating a domain-specific testing language.
Mm-hmm.
The result is a set of tests that are just much easier to read, write, and maintain.
So by investing a little extra effort up front, we can create a test suite that's not only effective, but also a joy to work with.
Exactly. And the book also suggests minimizing the number of assertions per test
Okay.
and really focusing on testing just a single concept in each test function.
So if a test fails, it should be immediately clear what concept is broken.
Exactly.
And I think we already touched upon the
Yeah.
FIRST principles earlier.
We did.
So we're starting to get a good grasp of what makes a clean test suite.
Absolutely. And remember, just like with production code, keeping tests clean is an ongoing effort.
Yeah, they can rot and become a liability if they're not well maintained.
It's true.
It's a good reminder to apply the same care and attention to detail to our test code as we do to our production code.
I agree.
Now, I know we've covered a lot of ground in this section,
We have.
but there's one more big topic I want to tackle before we wrap up this part of our deep dive.
Okay.
Concurrency.
Ah, yes. Concurrency.
It's something that can make even experienced programmers kind of nervous, you know?
It can be intimidating.
Yeah, and it's often seen as like a necessary evil, crucial for performance,
Right.
but notoriously tricky to get right.
It's true. You're right. Concurrency is a powerful tool, but it can also be the source of some of the most elusive and frustrating bugs.
The book doesn't shy away from these challenges,
No.
describing concurrency bugs as ninjas
Ninjas.
that lurk in the shadows and strike when you least expect it.
Yeah, they can be sneaky.
That's a pretty vivid image.
It is.
And what makes these concurrency bugs so tricky to deal with?
Well, Traditional debugging techniques often just fail us when it comes to concurrency.
Oh, okay.
The unpredictable nature of concurrent execution,
Yeah,
with its interleaving of instructions from different threads, makes it really difficult to reproduce and isolate problems.
right. Like trying to catch a ghost.
It really is.
You might see a fleeting glimpse of something strange,
Yeah.
but you can never quite grasp it.
So how do we even begin to approach writing concurrent code that's correct and reliable?
Yeah, how do we...
Well, the book provides some excellent guidance.
Okay,
First and foremost, it emphasizes the importance of minimizing the scope of shared data.
that makes sense.
The less data that's accessible to multiple threads, the less chance there is for conflicts and those race conditions.
And if you must share data,
Yeah.
the book stresses the importance of proper synchronization techniques,
Mm.
such as using locks or other mechanisms provided by the concurrency utilities in Java.
Yes, synchronization is key.
But I've also heard that overusing synchronization can lead to performance bottlenecks.
That's true.
How do we find that balance between protecting our data and maintaining efficiency?
It's a delicate dance. And there's no easy answer, but the book does provide a lot of helpful advice on how to choose the right synchronization mechanisms
Okay.
and use them effectively.
The book also provides this really valuable overview of common concurrency patterns and algorithms.
Yes.
Like producer-consumer, readers-writers, and dining philosophers.
These patterns are like tried and true recipes for solving these common problems that we encounter in concurrent programming.
So it's like having a toolbox full of proven solutions
Yeah.
that we can adapt to our specific needs.
Exactly.
Now, one crucial point the book stresses is the importance of getting your non-threaded code working correctly first
Yes.
before introducing concurrency.
It's tempting to try to tackle both problems at the same time,
Yeah.
but that often just leads to confusion
Right.
and makes it much harder to isolate the source of errors.
It's like trying to juggle while riding a unicycle.
Yeah, you're setting yourself up for failure.
Yeah.
By ensuring that your code works correctly in a single-threaded environment, you can eliminate a whole class of potential problems and really focus your debugging efforts on those concurrency-specific issues.
And when testing concurrent code, the book actually recommends running those tests in every potential deployment environment
That's important.
to uncover any platform-specific issues.
That's right, because concurrency behavior can be affected by factors like the operating system,
right.
the number of processors, even the version of the Java runtime environment.
So it's not enough to just test our code on our own machines.
Right.
We need to think about how it'll behave in the wild.
In the wild, exactly.
And the book also suggests instrumenting your code to try and force failures,
Yes.
especially in those tricky boundary cases where concurrency issues often lurk.
It's about proactively trying to break your code.
Okay, so proactively trying to break our code
Yes.
to uncover those hidden bugs.
Exactly. Techniques like stress testing or injecting delays
Okay.
can help expose race conditions or deadlocks
Right?
that might not manifest under normal conditions.
So it's like putting our code through this rigorous obstacle course
It is.
to ensure it can handle the unexpected.
Exactly.
Well, I think we've covered a lot of ground in this first part of our deep dive.
I think so too. We've gone from those foundational elements like meaningful names and well-structured functions all the way up to system-level design and the treacherous terrain of concurrency.
We sure have.
It's been a lot, but I think we've laid a solid foundation for understanding the principles of clean code.
Definitely.
The next part will delve into even more advanced topics, including concurrency, system-level design, and some of the common code smells that can indicate potential problems in our code base.
Stay tuned. It's about to get even more interesting.
So picking up where we left off,
Right.
let's shift gears from individual code elements to the bigger picture, like systems.
Right.
Clean code argues that just like lines of code, whole systems can be well-designed or messy,
Right.
and that has huge EE implications for maintainability.
I can definitely see that. As projects grow, even if you're careful at the code level,
Yeah,
things can easily get out of hand at a system level.
they can.
So what are some of the principles that the book highlights for keeping things clean at that larger scale?
Well, one of the core ideas is separating the construction of your system from its actual use.
Okay.
Think of it like setting the stage before the play begins. You wouldn't want the actors building props like in the middle of a scene, right?
Yeah, makes sense, but in code, those lines can get pretty blurry.
Right.
So how do you actually separate those concerns?
The book suggests a couple of practical approaches.
Right.
One is simply to move all that setup and initialization logic, that construction phase to your main function or dedicated modules.
Okay.
That way, everything else can assume the system is ready to go.
So it's like having this designated bootstrapping phase
Yeah.
where all the objects are created and dependencies are wired up.
Exactly. It makes the rest of your code much cleaner and easier to reason about.
Okay.
The book also delves into a more advanced technique called dependency injection, or DI for short.
I've heard that term thrown around a lot,
Yeah.
but I'll be honest, I'm still a bit fuzzy on what it actually means.
Yeah.
Can you break it down for me?
Sure. Think of it this way.
Okay.
Imagine you have a class that needs to use a database connection.
Okay.
Traditionally, that class might be responsible for creating and managing that connection itself. But with dependency injection, we kind of flip that responsibility.
Okay.
So instead of the class creating its own dependencies, those dependencies are provided to it from the outside,
Okay.
usually through its constructor or setter methods.
So it's like the class is saying, hey, I need a database connection to do my job, but I don't care where it comes from. Just give me one.
Exactly. And this inversion of control has some major benefits.
Like what?
Well, for one, it makes your code more modular.
Okay.
Classes become less coupled because they're not directly responsible for creating their own dependencies.
Right.
This makes them easier to test and reuse in different contexts.
That makes sense.
Now, the book also talks about this idea of scaling up systems without things falling apart.
Right. Because that's the challenge, right?
It is.
As systems grow, it's tempting to take shortcuts that seem convenient in the short term, but create a tangled mess in the long run.
Right, and clean code really argues that we should apply the same rigor to the construction and wiring of our systems as we do to the individual lines of code.
So just like we refactor our code to keep it clean and manageable, we need to be thinking about how we can refactor our systems as they grow.
Precisely, and one key point the book makes is that the startup process, where all those objects are created and those dependencies are wired up, should be modularized separately from the normal runtime logic.
Okay.
It's like having a clear separation between the stage crew setting up the scenery and the actors performing the play.
I see. So it all ties back to this principle of separation of concerns, which we've talked about before.
It does.
Now, the book also challenges a common assumption about system architecture,
Oh, yeah.
that it requires like this extensive upfront planning.
Right, and it kind of goes against what I've often heard about this importance of big design up front.
Mhm.
Clean code argues that just like we can refactor our code iteratively, we can also evolve our system architecture incrementally,
Okay.
starting simple and adding complexity only as needed.
So instead of trying to predict every possible future requirement and design for it from the start, we embrace the idea that the architecture will naturally emerge
Yeah,
as we learn more about the problem domain and the system's needs.
exactly. It's a more agile approach, allowing us to adapt to those changing requirements and avoid over-engineering early on.
Now, shifting gears a bit, the book also talks about the importance of domain-specific languages in system design.
Domain-specific languages.
So creating languages that are tailored to the specific problems we're trying to solve.
Yes.
That sounds pretty advanced.
It might sound complex, but the idea is actually quite simple.
Okay.
Think about other domains, like construction or music.
Okay.
They have their own specialized languages that allow professionals to communicate clearly and concisely about complex concepts.
So in software, creating a domain-specific language could help us bridge the gap between technical and non-technical stakeholders,
Yes,
making the code more expressive and easier to understand for everyone involved.
exactly. It's about using language that reflects the problem domain, rather than forcing everything into the constraints of a general-purpose programming language.
The book mentions a renewed interest in creating these DSLs, whether as separate scripting languages or embedded within existing languages.
That's right. And these DSLs allow us to write code that reads more like a natural language description of the problem we're trying to solve.
That's a fascinating concept.
It is.
Now let's talk about something a bit less glamorous,
Okay.
but equally important. Code smells.
Right.
What are those, and how do they help us write cleaner code?
Code smells are those subtle hints in your code that something might not be quite right.
Okay.
They're not necessarily bugs,
Right.
but they often indicate areas where the code could be improved in terms of readability, maintainability, or design.
I've definitely encountered code that just feels off, even if it technically works.
We've all been there.
Are there any specific code smells that the book highlights as being particularly common or problematic?
Well, one common smell is a high class in method count. It can be a sign that your code is overly complex and could benefit from some refactoring.
Right.
Imagine a house with hundreds of tiny rooms.
Yeah.
It would be a nightmare to navigate.
So it's like we're striving for that Goldilocks zone.
Yes.
Not too many classes, not too few, but just the right amount to keep things organized and manageable.
Exactly. The book also cautions against pointless dogmatism in coding standards,
Okay.
like insisting on creating an interface for every class even when it's not necessary.
So it's not about blindly following rules.
Right.
It's about understanding the principles behind those rules and applying them judiciously.
Precisely. Sometimes breaking the rules can actually lead to cleaner code.
And remember, the ultimate goal is to keep the overall system small,
Yes.
while also keeping functions and classes small.
But the book emphasizes that this is actually the lowest priority of the 4 rules of simple design.
And those rules are.
Having tests, eliminating duplication, expressing yourself clearly, and keeping the code small.
So while keeping the class and function count low is important, it's more important to prioritize those other factors first.
That's right. It's about finding that balance and understanding that sometimes making a piece of code a bit larger can actually make the overall system smaller and simpler.
Now, the book also has this extensive list of heuristics and smells.
It does. It's a lot.
It is, covering everything from inappropriate comments to overly complex conditional logic.
It's a lot to take in.
It is. We don't have time to go through every single item.
No, we don't.
But are there a few that you think are particularly relevant to our discussion?
Well, one is this idea of avoiding base classes depending on their derivatives.
So the parent class shouldn't have to know about the specific details of its child classes.
Exactly. The book argues that inheritance should be used to create this hierarchy of concepts,
Okay.
where the higher level concepts are independent of those lower level ones.
That makes sense. It keeps things modular and prevents changes in a child class from rippling up and affecting the parent class.
Right. Another smell is feature envy, where a function seems overly interested in the data or behavior of another class.
I've definitely seen code like that.
We all have.
It's like a function that's trying to do too much
Yeah.
and ends up reaching into other classes and messing with their stuff.
Exactly. And the book gives this example of a function that's supposed to generate a report of employee hours, but it ends up being cluttered with code that's really specific to a particular type of employee.
Right.
And the solution is to move that logic to the appropriate class, keeping things encapsulated and well organized.
It's like each class has its own private space.
Yes.
And other classes shouldn't be snooping around and messing with its belongings.
Exactly. The book also talks about avoiding selector arguments,
Okay.
those Boolean flags that we sometimes pass to functions to control their behavior.
I have to admit, I've used those before.
I think we all have.
They seem convenient at first,
Mhm.
but I can see how they could make the code harder to understand in the long run.
It's because you're essentially combining multiple functions into one, making it less clear what that function's purpose actually is.
So it's like having a light switch that also controls the toaster.
Right. Confusing and potentially dangerous.
So what's the alternative?
Instead of using a single function with a flag, create separate functions for each behavior.
Okay.
It makes the code more explicit and easier to understand.
So it's like having dedicated switches for each appliance.
Exactly. Much clearer and safer.
The book also emphasizes the importance of truly understanding the algorithm before you start writing any code.
Oh, absolutely. It's tempting to just jump straight into coding.
Right.
But if you don't have a clear understanding of the problem you're trying to solve,
Yeah.
you might end up with a solution that's more complex and error-prone than it needs to be.
It's like trying to build a house without a blueprint.
Exactly. You might end up with something that stands up,
Mm-hmm.
but it's probably going to have some serious structural flaws.
So taking the time to think through the problem and design a solid solution before you start coding will save you a lot of headaches in the long run. Speaking of avoiding headaches, the
Oh.
book also stresses the value of using standard conventions where possible.
Yeah, consistency is key.
When everyone on a team follows the same conventions for things like naming, formatting, and code organization, it makes the code base so much easier to read and understand.
It's like speaking a common language.
Yeah.
It reduces that cognitive overhead of trying to decipher someone else's unique style.
And finally, the book highlights the importance of choosing names that are unambiguous and clearly convey the purpose of a function or a variable.
Right. I mean, it seems like a no-brainer.
Yeah.
But I've definitely seen code where the names are so cryptic
Oh, yeah.
that it's like trying to solve a riddle.
It's like trying to learn a whole new language.
And the book really emphasizes that we should always strive to choose names that make the code read like a well-written story.
Okay.
clear, engaging, and easy to follow.
That's a great analogy. It reminds us that code is ultimately a form of communication,
It is.
and we should always strive to make it as clear and expressive as possible.
Now, since we're on the topic of readability, let's shift our focus to the world of testing.
Okay.
Clean Code has some very strong opinions about what makes a good test suite.
Yeah. It's not pulling any punches.
It argues that testing should never be an afterthought.
Right.
It should be an integral part of the development process.
Yeah, and it criticizes that seems like enough mentality
Yes.
when it comes to the number of tests.
The book advocates for a much more rigorous approach.
Okay.
Your test suite should test everything that could possibly break,
Okay.
leaving no room for ambiguity or assumptions.
Right.
It's about achieving a level of confidence in your code that goes beyond just hoping for the best.
So it's not just about having some tests. It's about having comprehensive and thorough tests that truly give us confidence in the code's correctness.
Exactly. And one of the key principles that the book highlights is that tests should be clean,
Okay.
just like production code.
It's easy to fall into that trap of treating test code as a second-class citizen,
Oh yeah, we've all been there.
but that can lead to a real tangled mess that's difficult to maintain and ultimately hinders our ability to test effectively.
It really does. The book shares this anecdote about a team that wrote dirty tests.
Okay.
Even though they had tests, those tests were so convoluted and complex that they ended up becoming a liability rather than an asset.
So they actually slowed them down
Yeah, it did.
rather than speed them up.
Exactly. It's a good reminder that if we don't care about the quality of our tests, they won't be able to effectively serve their purpose.
So how do we write clean tests? What are the key principles?
It really boils down to three things. Readability, readability, readability.
Readability, just like with production code.
Exactly.
But what makes tests readable?
The same principles that make all code readable. Clarity, simplicity, and density of expression.
Okay.
Saying a lot with as few expressions as possible.
Right.
Making the test's intent crystal clear.
The book provides an example from fitness,
Mm.
where the initial tests are really cluttered with details and repetition, making them difficult to understand.
Yeah, it's hard to see what's going on.
So how do they go about cleaning those tests up?
By applying the principles of clean code,
Okay.
extracting common logic into helper functions,
Okay.
creating a domain-specific testing language.
Okay.
And the result is a set of tests that are just much easier to read, write, and maintain.
So by investing a little extra effort up front,
Yes.
you can create a test suite that's not only effective, but also a joy to work with.
And the book also suggests minimizing the number of assertions per test,
Okay.
really focusing on testing a single concept in each test function.
So if the test fails, it should be immediately clear what concept is broken.
Exactly. And we've already talked about those FIRST principles.
Right.
So I think we're starting to get a good grasp of what makes a clean test suite.
Absolutely. And remember, just like with production code, keeping tests clean is an ongoing effort.
Tests can rot and become a liability if they're not well maintained.
That's a good reminder to apply the same care and attention to detail to our test code as we do to our production code.
I agree.
Now, I know we've covered a lot of ground in this section, but there's one more big topic I want to tackle before we wrap up this part of our deep dive. Concurrency.
Concurrency.
It's something that can make even experienced programmers kind of nervous.
It can be intimidating.
And it's often seen as like a necessary evil, crucial for performance, but notoriously tricky to get right.
It's true. Concurrency is a powerful tool, but it can also be the source of some of the most elusive and frustrating bugs you'll ever encounter.
The book doesn't shy away from these challenges,
Mhm.
describing concurrency bugs as ninjas that lurk in the shadows, striking when you least expect it.
Ninja, yeah, it's a good analogy.
That's a pretty vivid image.
It is.
What makes these concurrency bugs so tricky to deal with?
Well, traditional debugging techniques often just fail us when it comes to concurrency. The unpredictable nature of concurrent execution, with its interleaving of instructions from different threads, makes it really difficult to reproduce and isolate problems.
It's like trying to catch a ghost.
It really is.
You might see a fleeting glimpse of something strange, but you can never quite grasp it.
So how do we even begin to approach writing concurrent code that's correct and reliable?
How do we?
Well, the book provides some excellent guidance.
Okay.
First and foremost, it emphasizes the importance of minimizing the scope of shared data.
That makes sense. The less data that's accessible to multiple threads, the less chance there is for conflicts in those race conditions.
Precisely. And if you must share data,
Right.
the book stresses the importance of proper synchronization techniques, such as using locks or other mechanisms provided by the concurrency utilities in Java.
But I've also heard that overusing synchronization can lead to performance bottlenecks.
That's true.
How do we find that balance between protecting our data and maintaining efficiency?
It's a delicate dance, and there's no easy answer, but the book provides a lot of helpful advice on how to choose the right synchronization mechanisms and use them effectively.
The book also provides a really valuable overview of common concurrency patterns and algorithms,
Yes.
like producer-consumer, readers-writers, and dining philosophers.
These patterns are like tried and true recipes for solving common concurrency
So
problems.
it's like having a toolbox full of proven solutions that we can adapt to our specific needs.
Exactly. Now, one crucial point that the book stresses is the importance of getting your non-threaded code working correctly first before introducing concurrency.
Okay?
It's tempting to try to tackle both problems at the same time, but that often just leads to confusion and makes it much harder to isolate the source of errors.
It's like trying to juggle while riding a unicycle.
You're setting yourself up for failure.
You are.
By ensuring that your code works correctly in a single-threaded environment, you can eliminate a whole class of potential problems and really focus your debugging efforts on those concurrency-specific issues.
And when testing concurrent code, the book recommends running those tests in every potential deployment environment to uncover any platform-specific issues.
Right, because concurrency behavior can be affected by factors like the operating system, the number of processors, even the version of the Java runtime environment.
So it's not enough to just test our code on our own machines. We need to think about how it will behave in the wild.
In the wild, exactly.
The book also suggests instrumenting your code to try and force failures, especially in those tricky boundary cases where concurrency issues often lurk.
Yes, it's about proactively trying to break your code.
So proactively trying to break our code to uncover those hidden bugs.
Exactly. Techniques like stress testing or injecting delays can help expose race conditions or deadlocks that might not manifest under normal conditions.
It's like putting our code through a rigorous obstacle course to ensure it can handle the unexpected.
Exactly.
I think we've covered a lot of ground in this second part of our deep dive.
I think so too. We've explored system-level design principles, tackled the tricky topic of concurrency, and learned how to recognize those subtle code smells that can indicate potential problems.
We sure have.
We've made significant progress in our journey towards mastering the art of clean code.
We have.
In the final part, we'll revisit concurrency, exploring even more techniques for writing robust and reliable multi-threaded code, and we'll wrap up with some final thoughts and key takeaways from this book.
It sounds good. I'm ready to dive back in. Welcome back to our deep dive into clean code. We've covered a lot of ground already, from those foundational elements like meaningful names and well-structured functions, all the way up to system-level design and the treacherous terrain of concurrency. So where are we headed in this final stretch?
Well, we're going to circle back to concurrency and dig even deeper into techniques for taming those multi-threaded beasts. Then we'll distill some of the key takeaways and leave you with some final thought-provoking ideas from the book to chew on.
Sounds good. Let's dive in. I'm ready to level up my concurrency game.
Excellent. Now, remember how we talked about those concurrency bugs being like ninjas hiding in the shadows and striking when you least expect it?
Yeah, and how traditional debugging techniques often fail us when we're dealing with the unpredictable nature of multi-threaded execution. It's like trying to catch a ghost.
Exactly. So what can we do to make those ninjas a little less elusive and a little less dangerous? Well, one of the key principles the book emphasizes is to keep your concurrent code as simple as possible.
Okay, that makes sense. The more complex our concurrent code gets, the harder it becomes to reason about, and the more likely we are to introduce subtle bugs.
Precisely, the book actually uses a great analogy to illustrate this point. It compares writing concurrent code to juggling chainsaws.
Okay, that's a pretty intense image.
The point is, juggling chainsaws is inherently dangerous even for a skilled juggler. And adding more chainsaws to the mix just increases the risk of something going wrong. Similarly, with concurrent code, each thread is like a spinning chainsaw. The more threads we introduce, the more complex the interactions become, and the more likely we are to make a mistake that leads to a nasty bug.
So the takeaway here is to keep our concurrency as simple as possible. Don't introduce threads unless absolutely necessary, and if you do, keep the interactions between them as straightforward as possible.
Exactly. Now, another important principle the book highlights is to design your code to be thread safe from the ground up. Don't try to bolt on concurrency as an afterthought.
What does it mean to design code to be thread safe?
It means thinking about how multiple threads might interact with your code and ensuring that those interactions don't lead to data corruption or unexpected behavior. This might involve using appropriate synchronization mechanisms like locks or designing your classes to be immutable where possible.
I see. So it's about anticipating potential concurrency issues and addressing them in the design phase rather than trying to fix them later on when they inevitably pop up as those hard to debug ninja bugs.
Exactly. It's much easier to prevent concurrency problems than to fix them after the fact. And one way to help prevent those problems is to follow the principle of confinement.
Confinement, what's that all about?
It's the idea that you should limit the scope of shared data as much as possible. If data is only accessible to a single thread, then you eliminate the possibility of race conditions or other concurrency issues.
That makes sense. Fewer shared resources means fewer opportunities for conflicts.
And if you do need to share data between threads, the book recommends using well-defined synchronization mechanisms like locks or semaphores. These mechanisms allow you to control access to shared data and ensure that only one thread can modify it at a time.
So it's like having a traffic light at an intersection to prevent collisions.
That's a great analogy. And when using locks or other synchronization mechanisms, the book stresses the importance of keeping the critical sections of your code as small as possible.
What's a critical section?
It's the portion of code where a thread has exclusive access to shared data. By keeping these critical sections small, you minimize the time that other threads have to wait to access that data. This helps to improve performance and reduce the risk of deadlocks.
So it's like having a very short green light at that traffic intersection so that cars don't have to wait too long to get through.
Exactly. And speaking of deadlocks, the book provides some excellent advice on how to avoid these nasty situations where two or more threads are blocked forever, each waiting for the other to release a resource.
I've heard horror stories about deadlocks bringing down entire systems. They sound like something you definitely want to avoid.
Trust me, they are. And one of the best ways to avoid them is to establish a clear order in which locks are acquired and released. If all threads follow the same locking order, then you can prevent those circular dependencies that lead to deadlocks.
It's like having a set of rules for how cars should proceed through a complex intersection. If everyone follows the rules, you can prevent gridlock.
Exactly. And another important technique for avoiding deadlocks is to use timeouts when acquiring locks this way. If a thread can't acquire a lock within a reasonable time, it can give up and try again later.
So it's like having an escape row in case the traffic light malfunctions.
Right. And the book also recommends using try-finally blocks to ensure that locks are always released, even if an exception occurs.
That's like having a fail-safe mechanism to make sure the traffic light always returns to its normal state, even if there's a power outage.
Precisely. Now, we've talked a lot about the technical aspects of concurrency, but the book also emphasizes the importance of testing concurrent code thoroughly. And one of the best ways to test concurrent code is to try to break it.
That sounds a bit counterintuitive. Shouldn't we be trying to prove that our code works, not break it?
It might seem strange, but by deliberately trying to create conditions that expose concurrency bugs, we can increase our confidence that our code is truly robust and reliable. This might involve running tests under heavy load, injecting delays, or using tools that simulate different concurrency scenarios.
So it's like putting our code through a rigorous stress test to make sure it can handle the pressure of real-world concurrency.
Exactly. And when testing concurrent code, it's also important to remember that the results of a test might not always be deterministic.
What does that mean?
It means that the same test might produce different results each time it's run, depending on the timing of thread execution. This can make it difficult to pinpoint the source of a bug, but it's important to be aware of this non-deterministic behavior and design your tests accordingly.
So we need to be extra vigilant when testing concurrent code and be prepared for the possibility of inconsistent results. It's definitely a more challenging area of software testing.
It is, but the book provides some helpful strategies for writing effective tests for concurrent code, such as using logging to track thread execution and designing tests that focus on specific concurrency scenarios.
All right, so we've covered a lot of ground on concurrency, from keeping things simple to designing thread-safe code to testing thoroughly. Any final words of wisdom on this tricky topic before we move on?
Just remember that concurrency is a powerful tool, but it's also a double-edged sword. Use it wisely, and always approach it with a healthy dose of respect and caution.
Excellent advice. Now, I know we're getting close to the end of our deep dive, so let's start wrapping things up. What are some of the key takeaways from clean code that you think our listeners should really take to heart?
Well, one of the overarching themes of the book is that code is a form of communication. We're not just writing instructions for a machine, we're writing code that other humans will need to read, understand, and maintain.
And the book argues that just as we care about the clarity and effectiveness of our written and spoken communication, we should care about the quality of our code.
Exactly. We should strive to write code that's not only functional, but also elegant, expressive, and easy to understand. It's about treating code as a craft and taking pride in the quality of our work.
And one of the best ways to improve the quality of our code is to follow the principles outlined in clean code. Things like choosing meaningful names, writing short, focused functions, keeping classes small and well organized, and being mindful of those telltale code smells.
Absolutely. These principles provide a solid foundation for writing cleaner, more maintainable code. And the book also emphasizes the importance of continuous improvement. We should always be striving to learn and grow as programmers and find new ways to make our code better.
And that journey of continuous improvement is something that every programmer should embrace. It's not about achieving perfection. It's about constantly seeking ways to improve our craft and write code that we can be proud of.
Exactly. Now, as we wrap up our deep dive into clean code, there's one final thought from the book that I think really captures the essence of what we've been talking about. Code is, in essence, a language we design to describe our systems.
That's a powerful statement. It reframes our role as programmers. We're not just coders, we're language designers. And the quality of our code reflects the quality of the language we've created.
So the next time you're coding, think of yourself as a language designer. What kind of language are you creating? Is it clear, concise, and expressive? Or is it convoluted, confusing, and hard to understand? The choice is yours.
That's a great note to end on. Clean code isn't just about following a set of rules, it's about embracing a mindset of craftsmanship and constantly striving to write code that's not only functional, but also a pleasure to read and work with. Thanks for joining us on this deep dive into the world of clean code.
Yeah.
Hopefully you've gained some valuable insights that you can apply to your own projects.
And remember, the journey doesn't end here. Keep learning, keep experimenting, and keep striving to write the best code you can.